are all around us. From the bricks in a wall, to the rings in a tree, to the weather, to the design of your favorite sweater. Hi, I'm Sarah Porcnellic, and today we're discussing AR.3.1, which calls for 5th grade students to identify and write a rule that can describe a given pattern as an expression. In this 5th grade standard, it's important to note that rules are limited to 1 or 2 operations using whole numbers. In mathematics education, teaching concepts using the concrete, representational, and abstract sequence is often used in teaching skills such as multiplication and subtraction. However, often in concepts relating to geometry and algebraic reasoning, it's less utilized. The CRA, or concrete, representational, abstract approach, can be highly beneficial for teaching all mathematical concepts. This approach has been shown to be effective in raising academic achievement in schools with at-risk students. So, how could we potentially use this CRA concept to teach this standard? Let's take a closer look. In the concrete phase, manipulatives are used to teach a concept. We can represent patterns using manipulatives to see how they grow or shrink. Here's an example. Let's say you have the numerical pattern 6, 8, 10, 12. Let's represent this concretely to help us identify and write a rule to describe this pattern as an expression. Students can use colored tiles for this and physically move them around to try to figure out how the patterns are growing. For this video, I'm just using virtual manipulatives, but you'll want to give your kids physical things to move around. So we'll make 6 tiles, 8 tiles, 10 tiles, and 12 tiles. You can then guide students through a conversation about how they view this pattern changing. It's important to note that there are more than one correct response in many cases. In this pattern, I see that we've started with 6 tiles, and then each term added more. The second term, I added 2 more tiles, in the third term 4, and in the fourth term 6 were added. So to me, it appears that we have a base group of 6 tiles, and then add a certain number of tiles in groups of 2. To test this out, have students add on to the pattern using their reasoning to check their work. So let's go ahead and figure out the 5th term. In my understanding, I start with 6 and then add a certain number of groups of 2. For the first term, I added 0 groups of 2, then 1 group of 2, and so on and so forth. So for the 5th term, I will again start with my base 6 and then add 4 groups of 2 or 8 more tiles. Therefore, my output is 14. Teaching this standard, it's often helpful to make an input-output chart with these explanations. So you see here, the input, or X, is 0, 1, 2, 3, 4, and so on. My outputs are 6, 8, 10, 12, 14, and so on. And my expression to represent this pattern is 6 plus 2x. Remember, however, that there are other expressions you can use depending on the input. Let's take a second quick look at another way students may think about this. Here, I've represented the pattern visually like this, and I see these blocks building based on how many groups of 2 are in each. In the first, I have 3 groups of 2. The second is 4 groups of 2. The third is 5 groups of 2, and so on. Therefore, my pattern is 2x, where x equals 3, 4, 5, 6, and so on. The next stage in the CRA approach is representational. In this stage, students can draw the patterns to make sense of them rather than using the manipulatives. It's often helpful at this time to add context to your patterns so students can have something to draw. Let's look at another example. In this instance, we have 2, 7, 12, 17. For this one, let's pretend we have tables and chairs. For one table, we will have 2 chairs. 2 tables is 7 chairs. 3 tables is 12 chairs, and so on. In this, I personally see a constant 1 table with 2 chairs. So again, we'll always start with those 2 chairs. I can see from the pattern we had groups of 5 chairs each time, because this is how I drew it. Let's take a look at the table as we create our expression. We have x equals 0 as our input because there's no groups of 5 chairs. Then we have 1 group of 5, 2 groups of 5, and so on. So our table would look as so. To create our expression, talk through it with students. You have 2 chairs to start and add X number of groups of 5 chairs. This is a difficult concept for some students, as they may need to see examples of how these patterns can be visually represented or drawn before creating their own. They also have to follow a pattern, so creating a random number of chairs and tables for each number won't work. The last phase is the abstract, focusing on numerical procedures. At this point, it's helpful to have students create the input-output table alongside the pattern to create the expression. For example, let's put this pattern 9, 13, 17, 21 into an input-output table. I again see that we have 9 to start and then add 4 more each time. So, similar to the first example, my pattern can be 9 plus a certain number of groups of 4. For the first term, there are 0 groups of 4, so that's the first input. Then 1 group of 4, 2 groups of 4, and so on. So my final expression is 9 plus 4x, with x being 0, 1, 2, 3, and so on. At first, patterns may seem intimidating because there are different ways of seeing the pattern. However, this is a part of mathematics we rarely focus on, that there's not just one way to solve or even one answer. It's the justification and process that we care about. Helping students to create and justify patterns using manipulatives, drawings, and context can help them move towards an abstract understanding of patterns. Students may even start to love seeing how many different answers and expressions they can create with a given pattern. And do I dare say it? Have fun? Until next time, thanks for listening.